Hello, welcome back, Cygeeks, and welcome if you are new to this channel. Today we are going to do a follow-up on the last episode that was an introduction about what we are going to build in this context. So, if you're okay with that, I will start recapping what we did last time, the graphics and all the plans, basically all the steps that we are going to do in about 5 minutes from now. But one thing I want to do also to make all of you comfortable and make some time to build and to connect to the streaming, I will go into a question and answer mode to see if anyone that is connecting wants to present himself. Just a couple of minutes really, if you want, and then we start with the schema and with the steps that I planned to do today. It will be brief as the previous one. I'm not want to make you lose too much time every time, so I'm going to trying keeping the session as short as 30-40 minutes. I think that's kind of the golden blend of a session where you can give some attention, and so there is no reason to keep them longer than this. All right, so let me check if there is any comment in the chats from. We are live from YouTube, Twitch, and X. I think in LinkedIn is not working right now, but yeah, let me check. No, most probably is not working on LinkedIn. Anyhow, there is a link there for the other channels, so we should be fine. All right, so just a few seconds more, and if I see no comments or other people connecting, I'm going ahead with the presentation. Okay, so let me, maybe it's more useful if I show the chat here in this way. So last time I already shared the link for this whiteboard. If you want to follow up directly from here. And also some useful link that we are going to use today. So while I'm waiting. All right. So these are all the tools that we are going to use today. Cool. All right, so I think it's really time to get started. And without further ado, let's recap what we did last time. So, well, we took the schema starting from a simple idea. We want to get cloud resources to talk to third-party providers, being them SLURM or GPU renting clouds or whatever. And I want my main Kubernetes cluster to be able to talk to these remote resources in the easiest way possible. I'm not saying that we are going to see the easiest way, but to me, and for the purpose of the tool that we are going to use, this question mark, this is one of the easiest way. Let's put it in this way, okay? Wait. Yeah, so that's it. You have this magic tool here that whenever a framework. We are also going to look deep into the machine learning and data science framework that I think are the most easier to install and to manage, and that provide you a set of complete end-to-end knobs, at least, that you can turn in order to customize your environment as you wish. So, all right. Suppose that you want a Jupyter Hub, you log in, and you want your session, your notebook to be spawned on a supercomputer. The supercomputer usually is running a SLURM batch system. And okay, so what you can do at this point? I can install my Jupyter Hub on a Kubernetes cluster, so in the cloud, generally speaking. And then I want to ask this hub to spawn my notebook on a remote site. How can I do that? Well, I need a concept. I need something that make something magic like this happening. So I want to register a new node in the system that I will call virtual kubelet. So the kubelet, for whoever doesn't know what it is the main daemon that is ran into the node of a Kubernetes cluster. So in a certain sense, this is, let me zoom in. This is pretty much a virtual node, okay? Virtual node, what does it mean? It means that I will see this entity just like a normal node on a cluster, but whenever a pod is assigned, if a pod arrives here, and this is assigned to the virtual kubelet node, so to the virtual node, the tool that I'm going to present, well, the tools that I'm going to present leverage a concept and a software that is part of the Cloud Native and Computing Foundation that is called Virtual Kubelet. No surprise in that. We make a call to a remote system, say, okay, I want to run this pod that contains this set of containers, this set of volumes and config maps and secrets and whatever. I want this to be run somewhere else. So what we are going to test today is having a VM where you have SLURM for the submission of a job on a batch system. And then you're also going to run the other requirement on this VM that we are going to install is running a container runtime. So it won't be, in many cases, you won't have Docker on the supercomputer. So we are going to simulate that, and we are going to use Aptainer. Aptainer or Singularity are mostly the same tool. So let me put the reference here in the chat. All right. So it's actually a container runtime that you can leverage to execute any kind of containers. So just a brief recap. Holy cow. Sorry. Okay, so just a brief recap. The first two steps that we are going to do is install SLURM batch system on a virtual machine that we instantiated last time, and also to install Aptainer on the very same machine. Then we put aside the virtual machine and we take back our Kubernetes cluster that we instantiated on sivo.com. Please refer to the link I shared with you last time, or take a look at sivo.com. So, sivo.com. You see now? Yeah. This one is the tool, is the cloud provider that we are going to use. It's super fast in providing Kubernetes cluster. You can install app already out of the box. We install Vue, an ingress, and a cert manager just to speed up our procedure. So take a look You take for free $250, I think, if you register right now. So take a look, definitely. So as I mentioned before, we took this Civo.com cluster, and then we installed on top of that this virtual node. Again, just to summarize, first we install the VM today, and then we install the virtual kubelet. Or at least we start looking at the documentation at the virtual kubelet installation, and if we run out of time, we can go ahead and do this next time. All right. So we are all good with that. Yeah, I see no objection in the chat. We can go and proceed with just a bit of introduction of what is a virtual kubelet and how this relates to what we are going to do today. All right. Virtual kubelet, as I mentioned before, you can see here, is a sandbox project of the Cloud Native Foundation. So it's not nothing but open source and with a strong support behind that. And so yeah, you don't have to care about these things. You can go into the documentation because I just want to show you a synthesis of what I mentioned to you before. You have your Kubernetes cluster with a lot of physical kubelet on every single node that you're running, and then you introduce a virtual one where you can do whatever you want. And what we are going to make it doing today is submitting a SLURM job, running a container in a container runtime that in this case would be Aptainer. Cool. So why am I talking about virtual kubelet? Well, virtual kubelet comes with a set of providers. No one of them support SLURM so far. And in particular, each one reintroduce very different integration with the Kubernetes state machine, caching, and so on and so forth. So what was our idea? Our meaning the INFN initiative. INFN, if you saw already my old videos, you know that that is the Institute of Nuclear Physics in Italy, and it's responsible for providing the development and the support part for the interlink tool that I'm just about to talk about. And the interlink itself, it's also developed in the context of a European project that is called InterTwin. That is a project that aims to produce a digital twin engine for a vast sort of community that span from the high energy physics to the geological and fluid prediction and so on and so forth. So very cool projects, and this is no exception. Interlinks has a simple reason in mind. Creating virtual kubelet takes some expertise in Kubernetes internals, and it's really bounded to people that are able to understand this kind of mechanics. The idea then is, why not to take away from the final users or from the administrator of a remote site the burden of understanding how virtual kubelet works, but rather we take care centrally, once for all, of all the technicalities around the kubelets and the state machine of Kubernetes, and also and so on and so forth. And this is happening in this orange and purple part. And then we let the administrator, the users, develop an ecosystem of plugins that are simple web servers that should be able to manage the life cycle of a pod. So running, status, kill, and logs can be written in any language. And that's the beauty of this implementation. So you have this kind of level down here. Let me zoom in, where you can get really up and running very fast for your environment. we're going to use the SLURM implementation today. So let's start and we see how this works out. I stop briefly. Just let me know if you have any question at this point. Or if you join later, or if you joined late, just say hello. Okay. Yeah, I know it's Sunday for everyone. By the way, there will be a VOD for this, so you can catch it later. And also I can summarize all these first 2 episodes in a video later on, so you will find out also this. All right. Now we conclude the part of the virtual kubelet. I know it's more complicated than how it is in the practice. So the idea is we got already some videos in the past where I installed and I put you the references to all different steps. But one thing is doing live from scratch, really from scratch, and the other one is passing instructions. So the idea here is to get started from scratch so you can see all the steps. And to do that, we are going to start from actually the documentation that we have. So we set up a documentation where we get, at this point, a lot of information on how to actually install a sample example, a sample workflow to install your SLURM plugin. You see, you have different steps to install the purple and the orange part, and then you come to the SLURM job part. Okay? So finger crossed, and let's get started. As I mentioned before, we need, before starting, a virtual machine that we installed last time with sivo.com again. That is called Ancient Smoke, whatever. Is an automatic name. That's not my fault. So, cool. Let's start. 20 minutes already of talking. Sorry about that. It was supposed to be less, but I think it's good to have some introduction. All right. So I'm logged into the Ancient Smoke VM, and we are going to need some instruction to install SLURM on this. Last time I put you the references to the Docker file for the installation of SLURM that I have, so we can go ahead and copy this command. Hopefully everything should work out of the box. And in fact, it's installing. So while this is installing, let's take the other step. That is actually copying the docker slurm.conf file into etc/slurm.conf. And the slurm.conf file is this one, pretty standard, nothing special, really from documentation of the slurm, you can find everything you need. So, all right. No, please don't restart SSH, neither network. Okay. Perfect. Then, as I mentioned before, we copied this one, and we're going to vim etc/slurm, and the name was etc/slurm.conf. All right, and we copy this content there. Then we make sure of having the SLURM ctld directory installed, and we should be good to go. Yeah, so let's see what is in the startup script. All right, so we need exactly. So we need our host name to be put here. Host name. Oh, come on. Not the name, sorry. Not the name here. CPUs should be 2 and memory for what? I don't know what is the units of this, but yeah, this should do the work. Let's check it now. We start the authentication and the SLURMD. Okay, this started, SLURMD started, and if I do, yeah, skew minus me, oops, this is unknown host. Host name, yeah, it's this one. Let me check. Why is that? Probably. Does it need this? So restart, and restart. Service munch status. Okay, it's good. SLURMD status condition. Why? Let me check. Okay, Sivo 24 gigs. Plug SLURM. There is nothing here. What? Holy moly. This happens a lot. So SLURM come to etc slurm.conf. Yeah, now should be better, right? All right, we are almost there. Let me check if the skew command is working. Full name resolution. Okay, let me try this. Let me try this now with the right name. Let me put this one. And if still not working, we are going to put localhost and we forget about that. Okay. So SLURM restart. If you found any obvious in the chat, please let me know. Holy, okay. Localhost. Temporary file or name resolution. Anyone knows about this? Otherwise, we go ahead and we install Obtainer, and then we see this later. It happens, it happens. Let me check if there is an immediate response to this. Oh, let me see. Maybe it's for this reason. Let me check. Yeah, I don't know, man. Okay. Let me try just one last thing. So to install, we take host name here and we substitute with host name. Well, let's do the very same thing. Okay, let's try this. Host name and boom. Okay, now let's take a look. Well, I don't see anything different from before. All right, no question. No idea why it was not working, but now it's working. Okay, so I took the SLURM batch system command. I put everything that I can in the configuration, and we're good. So we have a SLURM cluster working. The other part that we need, it should be way simpler, is Obtainer. As I remember from before, while it's installing this, I remind you what we need. We need a container runtime, a SLURM cluster on a VM, and then we want to put this batch system in contact with a Kubernetes cluster, right? Through some magic machinery. And the magic machinery we are going to use is the interlink installation. So we are going to install interlink into a Kubernetes cluster. And today, I just put the basics for this kind of approach. So I'm installing SLURM and Obtainer. If we have enough time, I think we can go ahead at least another half an hour. We are going to install and to do all the guided procedure of installing this tool, so we can get a virtual node where we can send pod that are scheduled on our VM with a batch system. And the VM for the batch system, just for recap for who is connecting right now, it's the emulation of a supercomputer. The purpose of this episode are supercomputing on one side or GPUs on demand on the other one. So for today, we have a VM with SLURM. The next episode will be on a provider of GPU. In this case, will be CWeb. And finally, while we're doing that, we keep an eye also on a set of framework that we are we need in order to do, okay, I'm actually building a platform. I just don't need only the infrastructure part, I also need the frameworks. How these frameworks interact with my infrastructure is what really matters. So I'm about also to install these frameworks for interactive analysis, for tracking experiment, for machine learning, for instance, and then also dedicated frameworks for both classical or scientific machine learning, model creation, and inference, or more specific for generative AI. And in this context, I will focus on the ElixML initiative that I find very cool. And so keep an eye on this. And if you didn't already, subscribe to follow up all this longish stuff. It will take a while, different episode, but I think it's worth it to have an idea on how you can integrate all of this. Okay, so just a few seconds of pause to understand. Okay, no, do not restart this and this, please. Go ahead. I'm pausing for just 1 minute, 1 minute and a half. If you want to say hello, if you just connected, or if you have questions or you have preferences for next episode or for more, let's say, information, yeah, I'm here to answer for the next minute, minute and a half. I don't know if, yeah, I see. Yeah, definitely I see someone connected soon. Take your chance or say hello. All right, way too shy. Come on, guys. But yeah, I don't want to force you in any way. So let's get back to the to our stuff. So we have now Singularity installed. Singularity, which Singularity, okay, or Obtainer are synonymous, so you can use it. Are the very same container runtime. Container. Okay. Cool. So now we can put this node aside. It will be our remote node, and we go into the other interesting part. That is what is going to run on my laptop, meaning the installation of an additional node. The node of our Kubernetes cluster, the one on civo.com, is this one. So you see a couple of nodes at least that are registered. These are all physical nodes. So if you go in Civo, you see that I requested a Kubernetes cluster with 2 nodes and some application, a simple ingress and a load balancer and a cert manager to expose services. It won't be needed for the today exercise, but for the frameworks next times it will. We got the kubeconfig from the web UI, pretty nice, and then we export here, so last episode, and we get access to the cluster. We are ready. We are eventually 36 minutes in, and we are ready to do what we were supposed to do half an hour ago. Sorry about that, but some introduction were needed. Okay. So what we need for interlink is basically two things. A service that we run on our VM, on our remote site, that expose a port with a REST interface. And then we also need an identity provider in order to make the authentication between our Kubernetes cluster to the remote site. Okay? So if you agree with that, we can go and say, cool. Let's take a look to the documentation. So it says, go and install a client for application into the GitHub, your GitHub settings. And this is actually one of the possible identity provider that you can use. Generally speaking, as long as your identity provider respects the OpenID standard, you will be able to make it talk usable in this setup. Of course, we start with the exception. GitHub is not really OpenID, but is something similar that can be worked with. The tool that we use for the authentication, again, is something very open and at disposal of everyone. That is the O2 proxy project, right? So nothing special. You can take a look at the documentation here. Probably I'm going to leave you in the comments, in the chat also, the link to this. All right, cool. And then we need a configuration. So for this test, I'm going to use this documentation that is the one related to an OEDC provider, that is the AGI check-in. That is the one that we are using in the project, in the European project for authentication. So I had also ready this. At INFM, for instance, instead we use the Indigo IAM service. That is another identity provider for managing users and providing credentials through OpenID Connect. All right, so let's take this and we go. So you have three possibilities. The first one, you have no identity providers of your own. You can use GitHub and use this kind of follow step by step this information and screenshots, and you will be ready to go. The other one is, if you have something you can and you know already how to fill all the needed parameters, you can go here in the configuration that we are about to fill and set them as you wish. Then you need our installation script. The installation script of Interlink is, the idea behind that is that you provide everything in there, and then you get a YAML manifest for Kubernetes to set up the node, virtual node on the cluster, a setup script for the remote site to bring up all the services needed, and then a guide for your plugin to be installed. And this is what we are about to do. So we took our latest release. Please consider, this is just one notice, that this is an old version. As mentioned, maybe we can find a way to make it more explicit. For the latest release, you have to go to this page where there are all the releases, and you can download the one for your system. I have a Silicon ARM64 for Darwin, so I'm going to download this. Okay. I'm going to call it interlink install. Okay. So done, downloaded. And then we are also going to set up the init script. So move downloads, interlink install, and move it here, and then interlink install --init. Let me actually move what I did before so you can see that I'm starting from scratch. By default, the configuration part for the installation is put into home interlink.yaml. So I can increase already a bit the chart size. Yeah, maybe it was too small before. Okay, and I move it to interlink YAML backup. Okay. Let's see. Right, you need to remember to give executing permission to the file that you download. And then if you are lucky like me to be on a Mac, you need also security. You need also to take care of allowing the execution of third-party software. Yeah, allow anyway. Confirm. Good. Now, yeah, I'm sure. All right. So we installed everything, and if we now open the file that has been produced, as you can see here, we have to fill up a series of parameters. And these parameters are actually pretty useful. Oops. No, actually I wanted to switch it. Okay, never mind. So we need to provide the remote address of our VM, and this is pretty easy because we have it in Civil. We can go to the compute part and copy the public address, right? This will be the address exposed. Okay, then I will put, already I set the firewall to be executed on the that port 3443, and eventually RC4, the version of the interlink that you want to download, the kubelet node. So here we can put whatever we want. So SLURM node, SLURM remote node. Namespace is fine. We're going to install it in interlink namespace. We are going to have on that node just 2 CPU and 4 gigs of RAM. So we can and we can put also the limits. These are the ephemeral, the virtual resources that we are going to show on our node. And then there is the authentication part. For the authentication part, we can forget about this and use, since we have the possibility to use this other provider, I'm going to use this one. There will be no difference if you use the GitHub path. So just copy and paste all the steps, and if you find any issue, write me on interlink or whatever. Also in the interlink page, you see that there is a reference to how you can contact us. So if you go to the bottom of the page, there is the Slack channel of the community, so you can join in and make every question you want. All right, so cool. Everything should be done here. Your email here. So it should be like fan.it probably, or Changotini without Diego. This we are going to discover soon. And yeah, that's all. Coming back to the documentation, once we did everything, all right, so sorry for the zapping. Okay, you can find here in the documentation all the description and the configuration. Then you're ready to make the interlink install script running. And the magic will appear here because the script will take care to guide you step by step into the into the creation of a valid token to start the refresh chain, the OAuth chain of authentication. So you can, go ahead. Now device login successful, and the plugin should go add, and boom, that's ready. This all output is telling you what steps are exactly needed to do at this stage. So if everything works, not like before, everything works, now I can apply this into my Kubernetes cluster, and it will manage to do everything that is needed. So with some luck, get pod -n interlink. Yeah, we will have a pod running pretty soon. And this pod is responsible for the registration of the node. So here, describe pod. Okay, we are pulling images. This pod here is registering the part of the kubelet that is the purple pod. So here, this pod will register the node to the Kubernetes cluster. And then the other part of the instructions that we got before actually, is an installation script that we need to run on the remote part. So on the VM, at this point, we are going to have not this question mark anymore. We're going to have the interlink part. Okay, the interlink part, that is the one responsible to talk with a virtual kubelet, with a Kubernetes cluster, where the authentication and the translation of the pod execution command will be happening, and that this is the one responsible to talk to the plugin. Then we are going to see in a minute how it works. So that is the one responsible to submitting the jobs actually. So okay, SLURM plugin. Okay. So let's see. Okay. Get pod. Okay, it's failing for some reason. That's not too bad. Let's take a look. So you see, the interesting part of doing this from scratch is that every problem that you find, I can also be able to find. That's pretty cool because we can fix things together. So there are two containers in the spot, and you need to go for the correct one. But let me first of all check what we have here. So these are all the correct permissions. What we miss probably No, the name is correct. Okay, you see there are two pods in the deployment that we do for the virtual kubelet, and we need the logs for this one. So let's take a look to logs -c, name of the container. All right. So problem is that we are not able to get the token from your EDC. Let's check this out. The one responsible to take the token is the pod. It's inside the pod. There is a third image that is called refresh token. Okay, so let's check the log for this. That should be the one failing. Okay, so indeed the authentication is not working. Cool, this can happen. I don't think there is any useful time to put into here. So let me check just one more thing. That is the following. So we also add in this .interlink in my home another file that is the remote.sh. All right, so what I'm going to do, suppose that everything went well, we have the node ready to talk with the remote part. We are going ahead just like this working, and the next time we're going to look into the node actually working, and I show you how this node will appear here with the correct version of the virtual kubelet and with all the limits on resources that we set in the configuration. So let's stand by for this part until the next stream and go ahead with installation of the remote part. So just to be clear, we stand by for the installation of the blue, giving me time to understand why the authentication didn't work. It can be a temporary problem, as always in the weekend that happens. And generally speaking, not for the provider itself. And then we go ahead importing the installation script for the orange part. And to do that, we copy this into Ancient Smoke. That, if I remember correctly, yeah, at this IP. So, oops, it's root at this. We put in the home, and that's fine. Okay, now if we log in, cool, we should be able to follow up the instruction. So deploy interlink core component. Everything is documented, so what I'm doing is really step by step what is meant to work here. Probably if you used or you are going to use the GitHub, you would be much faster than me because you won't find the issue that I'm facing right now for the authentication. All right, then there is this nice initialization script. You have to do nothing, really nothing. If you configured everything correctly, you should be able to launch these two commands. The certificate for the authentication are created automatically. And okay, the install is done. And you should be ready to do this. And yeah, now we should have a couple of processes that are started, and one of them is the interlink binary. So we have the orange part up and running. Now this is the perfect time to interrupt, because next time we can recover from this, taking the node to work with the correct authentication and see how virtual node appear just like a normal node. So what we are going to do is essentially doing a get node, see a new node appearing here, and being able to do describe node, just normal nodes, to see all the limits and the resources allocatable, and so on and so forth. So this will be where we start next time. And probably you were seeing nothing of what I'm showing, and also I don't know how much time I was in this perspective. Hopefully not too much. Yeah, I was saying that we are going to resume from here, from the node that will appear just like normal nodes, but with the idea that these normal nodes are instead virtual. So they will be able to submit, instead of containers to the Docker runtime of the physical node, or containerd runtime of the physical node, they will be able to submit SLURM job and run the container into Obtainer. Very, very useful for supercomputing. And we see already people have fun with that, have real work with that in the interlink context, at also at INFN for doing actual science. So you use Kubernetes friendly workflows and frameworks from the user perspective, and seamlessly you are able to submit containers not only on the physical nodes of the cluster, but also to the physical node of a supercomputer. And that's super cool. And yeah, so we are starting from here. We are going to look at a fixed node, virtual node, able to run. And so it will be shown here. And then we go to the remote part. Holy moly. Okay. And then we go to the remote part, where we install, today we installed SLURM. So, and we installed also the interlink part, so they're responsible for submitting and translating the information from Kubernetes into SLURM jobs. And yeah, we bring everything up, we submit a pod to our Kubernetes cluster, and this will appear here into SQ, so as a SLURM job, and they will eventually finish and get back the logs from the Kubernetes cluster. This is the idea, and I think, again, we're going to need at least another hour, so another episode very soon. I think something around Tuesday or Wednesday, so we keep going. Yeah, that's it. A lot of stuff I can understand, a lot of information that we didn't have the occasion to go deep enough, but next time we'll try our best. And more importantly, don't get discouraged from this technical perspective, because the idea is, as I mentioned before, we are going step by step at our pace. We do everything really explicitly. I won't do anything outside the streaming, so you can see everything working as you will be able to reproduce. Yeah, it's time for questions if there are any. And thank you for watching so far, first of all. And please let me know for any information, or if you are trying to give it a try, let me know. I'm very interested to know your use cases. And yeah, I think we got a lot done today. So any questions before closing? Let me check. Okay then. So yeah, I don't see any. Let me thank you again. Hope this was a bit useful to understand where we are heading. There are some headache that can come from small things like authentication, as you see, or like SLURM instructions that are not working for mysterious chars in the string. But that's the good thing of the stream. You can go through them one by one. We assume most probably on Wednesday, Tuesday probably, maybe. Let's see. Stay tuned. Register to X, LinkedIn, whatever, Psygeeks Universe, YouTube, to get updated on the last date for, not last, on the next date for the streaming. So thank you again, everyone, and have a nice evening, morning, whatever, depending on where are you.